Greetings and good day to our lecturer, Mr. Mustaqim bin Tukiman. Today, our Group 5, would like to give a presentation on our problem-based learning, PBL, on the topic Principle of Linear Impulse and Momentum. But before we get into the presentation, I would like to introduce the group members of our group. First off, we have Delvinia Solomon, which is me, Goh Siap Peng, Farid Aiman, Ainur Ridwan, and Haikal Daniel. To start off our presentation, I would like to give an introduction. So, momentum. When we hear the word momentum, what do we think? Oh, there's a lot of momentum going on here. Whenever mostly we hear the word momentum in competition, in sports or elections, but the momentum we're gonna talk about is the physics side of momentum. So this momentum we're gonna talk about is the quantity of the body in motion, measured as a product of its mass and velocity. So we often don't look that much into momentum, but momentum, if you don't know, plays a key role in our daily life without realizing it in every activity. For example, how hard do we need to step on a brake pedal to avoid collision with another vehicle? Or how hard do we need to hit a tennis ball to make it go further? So these are the things about momentum. Now the next part we're gonna talk about is about impulse. Impulse, on the other hand, is a term that quantifies the overall effect of a force acting over time, or in simpler terms, the rate of change of momentum. As important it is to momentum, impulse play a key role in the real world. This is due to the fact that forces often are not fixed, as they may vary from zero and increase or decrease over time. So, hence working with these forces directly will make it more difficult.
Hi, my name is Haikal Daniel, and I will now talk to you about the basic theory. The principle of impulse and momentum defines how applied forces and moments affect an object's linear and angular momentum. The linear momentum, abbreviated L, is the vector mv. The direction of this vector matches that of v. Mass is constant, and the linear momentum vector has units of kilogram meter over a second. A vector, momentum has the same v direction as velocity. Since mass is a scalar, momentum will always follow the direction of motion when velocity is in a negative direction. An example, the opposite direction of motion, and vice versa when velocity is in a positive direction. Because momentum is crucial to comprehending motion, physicists like Isaac Newton referred to it as the amount of motion. Newton's second law of motion can be rearranged to illustrate how force and momentum are related. Force affects momentum. The linear impulse, designated I, is the integral f dt. It is a vector quantity that measures the impact of a force across the course of its action. It has units of nth or pounds and behaves similarly to f. A force's impact on an object is influenced by its strength, duration, and duration of action. Because it quantifies the impact of a force, the concept of impulse is helpful. The momentum of an object can be significantly affected by a powerful force acting briefly, such as the force of a tennis racket striking the ball. The same change in momentum may be produced by little force, but it would take longer to act. Now, recall that the rate of change of the center of mass linear momentum is equal to the sum of the external forces acting on the body. The formula is shown in this slide. And to obtain, divide both sides by dt and then integrate from t equals to t1 to t equals to t2. The formula is also given in the slide. The particle's final momentum is equal to its starting momentum plus the total of all applied impulses from time t1 to time t2. This is referred to as the linear impulse and momentum principle. It holds true for both rigid body motion and particle motion.
Hello, my name is Farah Ahmad and now I will present to you about the calculation from question 1. Okay, for the question, the 100 kilo stone is originally at rest on the smooth horizontal surface with a force 200 Newton and the at angle is 45 degree. So find the final velocity and the normal force with the surface exert the stone during the interval. Okay, first we must draw the free body diagram. Alright, and then from x-axis, we do the formula mvx1 plus sub of integrate fx dt with limit t1 and t2 equal to mvx2. So put the point at the equation and we get the v2 equal to 7.07 milliseconds. From the y-axis, we use the equation mvy1 plus sum of fy dt with the limit t1 and t2 equal to mvy2. Put the point, which is nc times 5 second minus cx1 newton times 5 second plus 200 newton sin 45, and then we will get nc equal to 839.58 newton.
Now we are on to discussion of question 1. So the way we solve the question is by drawing the free body diagram and determine all the force that involved in the question. You can refer the free body diagram from the calculation of question 1. As you can see from the free body diagram that we have drawn, the force that involved in the free body diagram is the normal force, the force of the stone, and the towing force. So we then determine all the information given and substitute all the value given into the principle of impulse and momentum to find its final velocity and normal force. So from the slide you could see the formula, principle of impulse and momentum, and then we would solve the equation by finding the final velocity and normal force and substitute all the value information that we have given. The final velocity is 7.07 meter per second and the normal force is 839.58 Newton.
For the calculation 2, we use the equation fx dt equal to m delta v. So we put the point is 1 over 2 times 4 times 2 times 600 plus 2 times 600 delta t equal to 150 times 9.81 sin 30 times 4 plus delta t equal to 150 times negative 4. So we get the t equal to 6.46 seconds. And then apply the impulse momentum equation to the entire interval. So we get the 150v equal to 714, and then we get the v is equal to 4.76 milliseconds.
On to question 2. First thing first is that in order to better understand the question, we must draw the free body diagram. We could refer the free body diagram in the question 2 or in the slide. So, and then we then would determine all the value given and substitute into the equation below to find the time at which the skip reversed and the velocity at t equal to 8 seconds using the impulse momentum equation. Once we find the delta t, we need to substitute into the equation below, which is t equal to 4 plus delta ts, which then would give us the value of t equal to 6.46 seconds when the skip reversed. Then we would use the impulse momentum equation to solve the velocity at t equal 8 seconds. Then we would get the value of velocity at t equal to 8 seconds is 4.76 meter per second.
Alright, for the question 3, we draw the free body diagram, and then we know that G1 is equal to G2. So we put the point into the equation and we get the V equal to 10.26I plus 13.33J millisecond. I is for the x-axis and J is the y-axis. So we must do the theorem Pythagoras equation, which is Vx2 plus Vx the power of 2 plus Vy the power of 2, and then we square root. Then we get the V total is equal to 16.83 millisecond. So for the direction, we use the tan theta equal to Vy over Vx, and then we get the theta is 52.4 degree.
Next is the discussion of question 3. As usual, we need to draw the free body diagram of the question as such as you can see in the slide. And then the system linear momentum is preserved since there is no additional external force acting on the plane of motion. Thus, we use the equation as such to find the velocity of each axis. You could see the equation in this slide, which is g1 equal to g2, and then we would get finally we would get the value of the axis is v equal to 10.26 I plus 13.33 j meter per second. This answer is presented in vector form. And finally, in order to determine the actual velocity and direction, we need to use the formula below, which is v equal to sed vx square plus vy square. And then for the direction, we use the tan theta equal to vy over vx. And at the end, we will get the value of the actual velocity, which is 16.63 meter per second, and the direction is 52.4 degree.
Calculation for question 4. First we draw the free body diagram, and then the second one we use equation mv1 plus the sum of f dt equal to mv2, which is the f we get is 467 Newton, and then we know that v2 from the x-axis is equal to v1 from the x-axis. So we use that equation to put v2 cos 40 degree equal to 35 cos 40 degree, and then v2 we get is 26.81 millisecond. So for v2 from y-axis is equal to v1 y-axis minus gt, is g is gravity acceleration and t is time. So we get the v2y equal to 12.69 millisecond, and then the total of v2 we get is 26.81 I plus 12.69 j, as I mentioned before. I is for x-axis and j is for y-axis, and then we know L2 is equal to mv2. So we put the point we get into the equation. So we get L2 is 1.18 kilogram millisecond.
Now on to the discussion of question 4. First, we need to draw the momentum impulse diagram to better understand the question. You could see the diagram in this slide. And then with all the information given in the question, we must use the principle of impulse and momentum to find the force, to which at the end we find the value of force is 467 Newton. Then we would find all the velocity that involved using the formula below, which is v2x equal to v1x. The value of each velocity that we found is that v1x is equal to 26.81 meter per second, v1y equal to 12.69 meter per second, and v2 is equal to 26.81 I plus 12.69 j meter per second. The v2 is presented in the vector form. And finally, we would solve for linear momentum using the formula L2 equal to mv2. And finally, we find the value of linear momentum is 1.16 kilogram per kilogram meter per second.
So lastly, for the question 5, first we must draw the free body diagram, and then we know that T is equal to nu n. So T we can get is 2452.5 Newton, and then T is equal to 400 T square. So we get that T is equal to 2.476 seconds. And then from the x-axis, mv1 equal to sum of fdt equal to mv2. So put the point we get into that equation, and v2 we get is 15.9 milliseconds.
And finally, discussion of question 5. First and foremost, we need to draw the free body diagram to better understand the question. To see the free body diagram in the slide. Then, we would need to determine the tension of the winch using the formula T equal to micro and Newton. The value of tension, or T, is equal to 2452.5 Newton. We then proceed to find the time T using the formula below, T equal to 400 T square, at which we find the T time is 2.476 seconds. And finally, to find the final velocity, we need to use the principle of impulse and momentum and substitute all the information into the principle. And the value of final velocity is 15.9 meter per second.
For now, I'll move on with the conclusion. So, in a nutshell, the principle of linear impulse and momentum can be applied in daily life and also counted as an important chapter to be mastered by engineers all over the world. For example, by playing tennis or other sport activities like badminton and so on, engineers can use their free time to calculate the impulse and also the momentum of the shuttle after playing any sports. Besides, in the group activities, we are able to do more research and also gain more knowledge deeply about this topic as our assignment. This is because we are able to do work as a team and also to discuss and find the interconnection between the principle of linear impulse and also momentum. By doing research, we also can find a lot of information, such as we can identify real applications of this principle and also provide visual imaginary to better understand with relevant information given. Instead of doing research on the internet, we also take the opportunity to find any dynamic exercise books to do more practice and also find the solution and also work in groups to complete the assignment given. Moving on, with enough knowledge and also information, we are able to explore deeply about how energy is lost and transferred during impact of collision between two bodies. For example, we have to solve 5 questions involving application in daily life to enhance our understanding or ability to solve any questions involving the principle of linear impulse and momentum. Moreover, working in a group can also gain better understanding towards the fundamental concept of dynamics. Last but not least, we are able to achieve all the objectives that we aim once we are given this group assignment and also able to complete all the study cases regarding application in daily life within the deadline given. That's all from our group. Thank you.